Understanding the High School Algebra Domain, Standards, Misconceptions, and Mathematical Thinking by Luquanda Jackson. Today, I will discuss the algebra conceptual category from the Your Mathematics Standards Companion for High School. The presentation focuses on three areas: the major clusters and standards within algebra, common student misconceptions associated with those standards, and a cognitively demanding task from the illustrative mathematics curriculum that promotes deeper mathematical thinking. Algebra serves as a bridge between arithmetic and higher level mathematics because students learn to generalize patterns, represent relationships, and solve complex problems. Before looking at individual standards, let's examine how the algebra domain is organized. The algebra conceptual category is organized into four major clusters. These clusters progress from understanding expressions to creating and solving equations. Rather than teaching isolated procedures, the standards emphasize conceptual understanding and mathematical reasoning. The four clusters are seeing structure in expressions, arithmetic with polynomials and rational expressions, creating equations, and reasoning with equations and inequalities. Students should learn not only to manipulate symbols, but also why algebraic procedures work. The first cluster focuses on helping students recognize structure within expressions. This cluster emphasizes recognizing patterns and meaning within algebraic expressions. Students learn to interpret parts of an expression in context. For example, in an exponential growth expression, students should understand what each value and parameter represents. They also learn to rewrite expressions to reveal important mathematical features. Look at the example. Rewriting the expression helps students recognize a perfect square trinomial. Let's look at some common misconceptions for this standard. Students often confuse terms and factors. They may view algebra as a set of procedures rather than a system of relationships. Many students also fail to recognize equivalent expressions written in different forms. Instructional focus is for teachers who should encourage students to explain what each part of an expression means rather than simply simplifying it. So once students understand the structure of expression, they begin with more complex algebraic expressions. This cluster extends students' understanding of arithmetic to polynomial expressions. Students apply properties they learn with whole numbers to algebraic expressions. They learn to add, subtract, multiply, divide, and factor polynomials. Let's look at the example. Recognizing structure allows students to simplify and solve more efficiently. Let's look at some common misconceptions for this standard. Students frequently combine unlike terms incorrectly. Many incorrectly cancel terms in rational expressions. Students sometimes treat variables as if they were ordinary numbers without considering algebraic rules. The instructional focus here is to use area models and visual representations, which can help students understand polynomial operations conceptually. The next cluster moves from manipulating expressions to creating mathematical models. This cluster focuses on representing real-world situations mathematically. Students translate verbal descriptions into equations and inequalities. They also learn to rearrange formulas to solve for specific variables. For example, a rectangle has an area of 60 square units. If we know the length, then we can solve for width. Some common misconceptions of this cluster are: students may assign variables incorrectly. Students often struggle translating words into mathematical symbols. They frequently reverse operations when writing equations from verbal statements as well. The instructional focus here is for students to benefit from authentic problem-solving situations that require mathematical modeling. So after creating equations, students must be able to reason through and solve them. This cluster focuses on solving equations while understanding why each step is valid. So students justify their reasoning and explain their solution or the process they went through in order to get the solution. Solving becomes more than finding an answer. It becomes a process of logical argumentation, and we want students to have that mathematical discourse. Some common misconceptions is that students forget to reverse inequality symbols a lot of times. So in this example, the sign should change because when you are dividing by a negative number, then the sign reverses. Omitting the negative solution when solving quadratic equations. This is a problem because the square root of 16 is a plus and a minus 4, not just a plus 4. So treating algebraic steps as a memorized process or memorized procedures rather than logical transformations. This happens a lot, and this is a very common misconception. The instructional focus here is for teachers to require students to explain and justify each step in their solutions. The standards encourage conceptual understanding, which is why cognitively demanding tasks are very important. So here I've selected an illustrative mathematics task from the Algebra 1 curriculum, and this task can be found in the Algebra 1 curriculum, Unit 6, Lesson 7. This is one of the first activities. I am very familiar with illustrative mathematics because it is actually the mathematical curriculum that my district follows. Also, I will say this, a lot of teachers, a lot of school systems follow the Georgia mathematical units. And within those units, there are a lot of illustrative mathematical tests that have been embedded. So whether you're following an independent such as illustrative mathematics or the Georgia learning plans, you will find these same type of tasks embedded. So the task here asks students to analyze multiple representations and determine which one doesn't belong. Which one doesn't belong is a type of instructional practice that is, or instructional routine, I should say, that is embedded into a lot of illustrative mathematics tasks. And you will also, once again, see these in the Georgia learning plans. So there is not a single correct answer. It's for the students to defend their reasoning using mathematical evidence. So why is this task cognitively demanding? It's because students are required to analyze patterns. They have to compare mathematical structures. They have to construct arguments and critique the reasoning of their peers. I love the discourse that happens in these types of tasks. This task supports making sense of problems, constructing viable arguments, and looking for structure, which are all mathematical practices. Why does this matter? Because instead of applying some memorized procedures, students are engaged in a higher order thinking and mathematical discourse. So tasks like this can also help teachers to students might have. High quality tasks help students identify the misconceptions before they become persistent. Students' explanation reveal their misunderstandings about, in this particular case, function types or the expression structure, variable relationships, or even the graph interpretation that we saw. Students may incorrectly, in this particular case, classify a quadratic function as a linear function because they focus only on a few points rather than the overall pattern. So teachers can use student reasoning as a formative assessment in order to guide their instruction. These ideas are very important implications for classroom practice. So here are some implications for teaching. Effective algebra instruction should balance procedural fluence with conceptual understanding. Students need opportunities to explain their reasoning, use multiple representations, engage in productive struggle, and participate in mathematical discussions. The algebra standards emphasize thinking mathematically rather than simply following procedures. Research consistently shows that students develop deeper understanding when they justify and communicate their reason. So to conclude, I will summarize the major points from today's presentation. So some key takeaways. The algebra domain is organized around the four major clusters again: seeing structure in expressions, arithmetic with polynomials and rational expressions, creating equations, reasoning with equations and inequalities. And each cluster builds students' ability to reason, model, and solve problems. Common misconceptions provide valuable information for instructional planning. Again, using tasks like the one that I presented would help a teacher to get some formative assessment data so you would better know how to plan instruction. Cognitively demanding tasks from illustrative mathematics helps to support deeper understanding and mathematical discourse. So just remember, when students are asked to explain, justify, and defend their thinking, they move beyond performing algebra to truly understanding it. Thank you for your time, and hopefully you have enjoyed my presentation.